Hey, good morning, everybody. This is going to be kind of a demo for any of you that missed class last week when we were talking about the acceleration, speed, and velocity. Um, so we will get right into it. So classwork is going to be where you find this assignment. And again, the acceleration, speed, and velocity. So I'm going to go through about the first 2 pages of assignment here, and then you'll have kind of the rest to do on your own. So when you open that up, it will look something like this. There's going to be a lot of information on these first 2 pages that's going to relate to average speed, average velocity, how we calculate those things, and then how we calculate acceleration as well. So when we look at average speed, that's going to be this, the total distance traveled divided by the time interval. And the average velocity is the total displacement traveled divided by the time interval during which the displacement occurred. So you can kind of see those equations there. And then again, we're going to do some examples. So this first one with average speed, while on vacation, Lisa Carr traveled a distance of 440 miles. Her trip took 8 hours. What was her average speed? So if we take our information here, we're going to go 440 miles was our distance traveled for the top. And if we look at our bottom, that's going to be our distance or time of travel. So that was 8 hours. And, if you take out your calculator and if you have a Chromebook, you should have access to a calculator in the Chromebook or use your phone. But if we divide those two by each other, we would get 55 miles per hour. And then this is something where it is important to have the correct metric and make sure everything lines up. So if it's meters per hour, meters per second, kilometers per hour, that's what it should be. In this scenario, it was miles per hour. So since we got that, it's going to be 55 miles per hour, taking 440 divided by 8. When we look at this total displacement question, we're going to do the total displacement is going to be he ran 10 meters away and then came back to the initial spot. So the displacement, again, is going to be how far away from the original spot you were. And in this scenario, he went 10 meters, but then ran back 10 meters as well. So those will eventually cancel out. And the time of travel was 5 seconds. So if we look at that math problem, it'll be 0 divided by 5, which would end up being 0 meters per second. So if you ever travel some distance and come back to that same spot, your average velocity will always be 0 because you're coming to the exact same spot. And just based on how velocity is calculated, it's a total displacement and you weren't actually displaced anywhere. So this is another maybe a little bit more complicated problem, but a car travels from city A to city B, which is 100 kilometers away. If the first half of the distance is driven at 50 kilometers an hour and the second half is driven at 100, what is the average velocity of the trip? So if we look at our average velocity, one thing we need to figure out is what our time is going to be here. So one way we can do that is through this time equals distance divided by speed. So we went 50 kilometers at 50 kilometers an hour. So again, the first half, which would be 50 of this 100. So if we do 50 kilometers divided by 50 kilometers an hour, our time frame to go the first half is 1 hour. We do the same thing for the second half of the trip, and we figure out that it takes 0.5 hours. So when we're doing our equation here, it is going to be 100 divided by 1.5. So this is going to be 100 kilometers, and then it's going to be 1.5 hours. And then we would divide those two things to get our final answer. So I'll let you guys kind of do that one on your own, but this is kind of where we would start.